So let's start uh, talking about uh, yeah. So MATLAB. So let's start talking now. Um, okay. Now we were talking. We talked about vectors, column and row vectors, especially different kind of products that you can take with the vectors. So for example, you could probably do a um, you can do a so you have Mhm. Just a So you can probably do a vector v, okay, if you have vector v square versus v square, okay. So maybe I need to write on the board itself. So these, so you remember the element by element squares versus the vector square itself. We had talked about that. There's a dot that must appear. So um, just a second. So for example, if you have vector v, okay, and this is like, let's say, a column vector, three numbers, okay, then if you do v dot, okay, I'm sorry, v dot star v prime, okay, sorry, v dot star v, that will give me uh, a vector that will get is v1 square, v2 square, v3 square, okay. So this dot is important here, okay. Now in the same manner, you can probably do the element by element multiplication of two vectors, okay. Again, you have to ensure that the two vectors are of the same kind, same shape, right? So suppose you have a is a1, a2, a3, and your B is B1, B2, B3. Then if you issue the command like day dot star B, should get me A1, B1, A2, B2, and A3, B3. Let's just check that. Okay. I hope that's correct, because even I do not, even well, I also do not, I also cross check everything, because I'm not in. These are the commands that are like roughly sketched in my mind, but or you should also get into the practice of checking these things, right? So let's say A is equal to, let's define a column vector, 2, 3, 1, 2, 3, and B as 4, 5, 6. Okay, then A dot star B is that 4, 10, 11, 4, 10, 18 is a product to the matrix. Remember, if I had issued the command A dot star B prime, it will get me something else. Okay, it's well, I think we had talked about that yesterday, right? It gives you a matrix if you have to do it element by element, right? All right. Now how to construct matrices, right? So now matrices are constructed again. Uh, Matrices are constructed. So constructing matrices. So constructing matrices. This is basically done using vectors. So you just line up the vectors and you construct matrices. Matrix, right? Line of vectors. So matrix is nothing but a set of vectors lined up. Vector is like a set of scalars, and matrix is a set of vectors. So in that sense, for example, you can have this row vector, another row vector, another row vector, and so on. just pile it up, you form a matrix, right? Uh, Alternate way of viewing the same thing, same matrix could be you can pile up, you can basically you can just put the column vector side by side or row vector on top of each other, right? So either way you can construct a matrix. Okay. So so let's say let's say I have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a very dumb looking matrix, but well, that's fine. All right, so uh, let's go back to our MATLAB, right? So you have A. Now let's define. By the way, you see that once I have defined A, B, and C over here, you can see A, B, and C are defined over are basically defined over here. A, B, and well, A and B are defined already. And there's a variable called ANS. I told you there's an answer that you get for the last calculation. This is a result of the last calculation. So you can see that in your workspace, you have already assigned A, B, A, answer, and B. These are the variables which have been already taken. You cannot. So next time, whenever you use A at your command prompt, it will basically take this vector, or B will be taken by this vector, or ANS will be taken as this matrix. Okay. So now, uh, so suppose I want to define a new vector. What you can do probably can just directly write again. You can type again, but at the same time, there's an option of erasing all this uh, variables which are currently in use. You can just forget all of them by issuing the command called clear, clear. Okay. So when you clear clear, sorry, clear, it should actually, um, why is it not? Yeah. So it has actually removed all the workspace variables. So now, so that is advisable when you are not sure whether, when you have large number of variables and you are not sure whether something is in use or not, and you want to start, either you check your workspace, ensure that, or just clear afresh. Okay, so that is one. So let's say I am going to write A equal to 1, 2, 3. That's a row vector. Okay. All right. Now this is sometimes annoying when you define, and then then your command console prompts it back. Like when I defined A equal to 1, 2, 3 and enter, and it just gives you this. So for example, if I defined a 100 by 100 matrix, and then if I hit enter, the entire matrix will be displayed, and it is kind of inconvenient for the user, right? So you can suppress getting the echo of the, or the getting answer variable echoed on your screen by putting a semicolon. I'm putting a colon here, right? Semicolon here, right? So that way, if I just hit, then nothing else happens. It just accepts the command that you have given. It doesn't reflect it back, doesn't bounce back, it doesn't echo your result. Okay. So okay, now so A is that, B is 4, 5, 6. Okay. Okay. So now I can construct a matrix A instead, like that. So 1-2 space 2 space 3, and then you have to put a colon. Okay, this is like going to the next row. Okay, so this is like hitting enter, then 4, 5, 6, and then 7, 8, 9. Okay, so now if I hit that, I'm going to get this. Okay, that's a matrix. Okay. All right. Let's say if I constructed column vectors like A equals to 1, 4, 7. Okay. You can give multiple commands in a single row. B equals, but they have to be separated by a colon, right? Semicolon. B equals to 258. Okay, and C equals to 369. Okay, and then let's hit enter. So if I just call A is this, B is this, and C is this. Okay. Now I want to concatenate them, right? So let's say I want to put them side by side so as to construct the matrix A. Okay. So A can be written as simply A, comma, uh, B, comma, C. That should work, I guess. Yeah. So if you just concatenate, so they have to be separated by commas, right? That is important. So otherwise, the matrix does not have a comma anywhere. Remember, a matrix or a vector, the elements are separated by space. But when you put a comma, you are actually concatenating it. So this is like joining column vectors, right? So this would be this is like joining column vectors. For some reason, the pen tab is not working properly on the MATLAB windows. It works all right with on the board. So this is column vectors, and it's very useful. Similarly, you could have probably you could have defined a row vector like this: 1, 2, 3, 4, 5, 6, and 7, 8, 9, and then stack them up together by just putting commas, right? So if you can do the same thing, for example, uh, say A equals to 1, 2, 3. Now these are row vectors. B equals to 4, 5, sorry, 4, 5, 6, and C equals to 7, 8, 9. Okay, just enter them. See, because you didn't put a semicolon here. That's why this command was prompted, but A and B did not get prompted. Okay, so that's uh, okay. All right. Um, so now suppose I construct a matrix B, which is now A, comma B, comma C. I'm sorry. Okay, so someone can tell me what mistake I made. Well, actually, I should have separated it using it's a next row, so I should have done this. Okay, so that gives me back the same matrix. So it's a rows stacking. When you go to the next row, there should be column. Okay. All right. So that is a way of constructing matrices, right? Now there are various things you can do on matrix. Before that, any question? No. All right. So there now things that we can do with a matrix. So let's see. Um, you know how to construct the matrix either by column putting the columns together or stacking the rows together. Okay. Um, now there's some operations on matrices. Let's see what are the operations we can do on matrices, right? So operations on the matrices. Okay. What can we do? So first thing, uh, so there's some functions like there's some mathematical functions like exp, and remember functions are always appearing with a name and a curved brackets with some inputs or input arguments here, right? So the typically uh, very frequently used functions, mathematical functions, very commonly used or very basic mathematical functions are listed here, but there's a whole bunch of such functions, and I'll tell you how to look them up. But let's say I have these functions. So these functions are inbuilt in MATLAB. Okay, so now you can give a scalar number here. It will give you to get you an answer. So log of 100. But you can also give vectors, right? You can also give a matrix over here. What does that do? So when you give a vector or a matrix, so let's say I have a matrix A, and A is set of numbers aij's, right? It's a matrix we all know. What it gives me is aij, another matrix which is aij square. Okay, so it's element by element, sorry, not square, but exponentiated. So it's element by element exponential, right? Exponential aij. Okay, you can say that this exponential a, you call this as a b matrix. Then b is equal to set of bij's, where bij is equal to exponential of aij. So for example, if I had a matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9, and if I just, this was my A, then exponential A would be e raised to 1, e raised to 2, e raised to 3, e raised to 4, e raised to 5, e raised to 6, e raised to 7, e raised to 8, and e raised to 9. Okay, and similarly goes with square root or log functions. Okay, so let's just show that. Now let's say I just did um, let's say I just did square root of b. Okay, I just hit this. So you're going to get this matrix, another matrix. The answer is again a matrix. Square root b is a matrix which is nothing but the square roots of individual elements. And similarly, you can do exponential of a. Okay, now this you have to be careful about. For example, if you have a matrix, what does our conventional sense, like whatever we are taught from the matrix theory, what does exponential of a matrix mean from mathematical, uh, from mathematics? This is what do we know as what is the concept of exponential of a matrix? How do you find out exponential of a matrix? Anyone knows? Anyone can answer me? What is the meaning of exponential of a matrix? I have a well-defined meaning of exponential of a number, e raised to x. And x, if I choose x a number, single number, I have a very well-defined meaning of that, right? So this we all know. Okay, there's a well-defined operation we can do to find e raised to x. What do you do to find exponential of a matrix? And this is definitely not this. Okay, this is not exponential of a matrix in mathematics, from mathematics or from matrix, actual matrix theory. Okay, does not say that exponential a is equal to this quantity. Okay, no, that is wrong. Okay, this is just this command is not actually the representative of the exponential of a as it is understood from matrix theory. Okay, this command is just a user friendly command built by MATLAB, so that you can take element by element, you can do element by element exponentiation, right? But actually speaking, what does exponential of a mean? Or for that matter, what does the square root of a matrix mean? Okay, so I should not be writing sqrt. Let me just say, uh, what does square root of a mean if a is a matrix? Does it mean element by element? Yes, absolutely. I guess one of you, so Rohit, you are absolutely right. Uh, so basically, exponential of a has a very specific meaning, or square root of a is a very specific meaning. What does that meaning? What is that meaning? Let's say square root of a. What is that? You can think of a matrix when, and by the way, these operations are always defined, like exponential of a or square root of a defined for square matrices. Okay, and for such matrices, if there is a matrix that when multiplied with itself gives me a, that would give me, so then b will be called square root of a. And similarly, exponential of a is nothing but a series expansion of 1 plus a square by 2 plus a cube by 3 factorial, etc. Okay. This kind of operation will give me another matrix, because remember, this is identity, not A, but identity of size n by n. This is also n by n matrix. A square will also be n by n. A cube will also be n by n. So when you're doing this in matrix theory sense, exponential of A means that. Whereas in MATLAB, the command that you issue exponential of A, well, maybe I should write this not as exponential of A, but I should write as like e raised to A. Okay, so e raised to A is this, and in MATLAB, exponential of A actually exponentiates uh, the A elements term by term, right? So element by if exponentiate the element. Uh, I don't know what to write this, but you understand what I mean. Elements. I think that's enough. Okay. So that is what exponential. So how do you actually calculate the e raised to a, what is understood from matrix theory? How do you do? Is there a way to find out actual e raised to a in MATLAB? Answer is yes. So for such cases, for such, so for example, if I have to find out square root of a in this sense, or exponential of a in this sense, okay, functions which end with m. Okay, so when you have square root m of a or exponential m of a, that is like matrix. M stands for matrix. Okay, so you are actually performing this operation in that case. Okay, so that is what we need to remember that. Okay, so all right, so that is uh, sometimes useful to know. So for example, here, let's say if I did this expm of a, I'll get an entirely different result, and it takes a little bit longer to calculate also. So you can see that exponential a, as shown up here, exponential a and exponential m of a is very different. Okay, um, so for example, let's say, um, let's say I define a matrix A. Okay, let's say what is A now? This is A. Let's find out A square, that is A into A. Okay, let's call that B. Okay, and B is this matrix, which is A square. Okay, so now if I give SQRT of B, I will not get back A again, right? That is wrong. But if I give you SQRT M of B, I should get back A again. No? SQRTB of so square root. No, I think what did I do now? Square root of A 2.645 2.42. A into A is B. So A should be square root of B. Square root of B. Now, I guess that should not have happened. Did I make a mistake somewhere? So let's just check. So, by the way, there's always you can always take help, right? So let me check what does SQRTM does. Principal square root of the square matrix. Say that x into x equal to a. Right. So x into x is equal to a. So therefore, a is this, b is this. B was obtained by now. Can anyone tell me what mistake did I make? Yeah. The way I defined B is not actually a into a. B would be equal to a star a prime. That should give me correct result. And then SQRTM of B should get me back. Uh, let's see, A is that. Let's check this. Let's do this on my. Okay, so you have A matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you multiplied A with A, um, you actually multiply like this, right? So I did not have to take A square is equal to 4, 5, 6, 7, 8, 9. Right, right. But that is not the result I'm getting, Rohit. Uh, am I square of B anywhere? Did I? Did I make a mistake? Did I make a mistake? We didn't use square of B anywhere. Let me check. Did I not? B equals to A into A. Let me just check. Just a second. Let me check the entries are correct. So what would I get here? 1 plus 8 plus 21. So first entry would be uh, 8, 8, guess should be 30, right? So, okay. So I guess this was correct. So, okay. So B is equal to A into A. That's fine. B equals to A star A. That is okay. So, SQRT M of B. I should get back A. Why am I not getting back A? What is wrong with this? So I should have. So you understand what I'm doing? I'm trying to just cross check whether SQRTM does the same thing. Define A star A with other variable. Meaning what? No, I don't. No, there's something wrong here. Maybe I need to check again. This should not have happened. I'm sorry about this. But that's what this also says. X into X is A. X star X is A. Then square root M A is X. I had A star A is equal to B. Then square root M B should be X. Square root for which every animal is non-negative real part. Okay. Mhm. Just a second. The principal square root of the square matrix A, that is X into X is A, right? And this A, I have this B. I'll get back to this later. I don't know what mistake am I making here. No, no, that will that work? No, that will not work. No, no, Chandra, that's not correct. That's that's exactly the point that I was trying to make. That's when you multiply vector when you multiply matrix, get a vector. Uh, um, so that's the point that I'm trying to make here is that a square that is obtained by multiplying a with a. Okay, and and the other way is you can take the individual elements squared, right? So that would be 1, 4, 9, 16, 25, 36, 49, 64, and 81. And then if you, this is your, let's say, C matrix, then square root C will give me A. That's fine. And if you define a B matrix that is obtained by B is equal to A star A, then square root of B should square root SQRT M of B should give me A back. But that's what is not happening here, and I'm puzzled why it's not happening. I'll cross check and get back to you. Let's move on now. Okay, it should have been that should not have happened. For some reason, I'm not getting the correct answer. Just check it once more. What is that I'm doing? That is Uh, well, uh, so why is it that way? This is correct, right? 30, 66, second row, second column is 66 आएगा, right? So second row, first column, 4, 20, 42. Yeah, that is 66. So that's correct. Mm, 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 mm. So this is fine. What am I doing here? Let me see. So this is A into A is B. Square root of B should have been A. I'm not getting A. Again, why am I not getting that? 2, 2, 4, 5, 5, 7, 9. I'll get back to you later on this. There's something that probably I'm missing here. Sorry about that. I'll get back to you. I'll clarify to myself first and get back to you. Okay, let's move on. Well, actually, no, they're not even close. Arunima, I'm just looking at your answer. They are actually not close. So A is 1, 2, and 3. So if you look at these numbers, this is not 1. This is definitely not, well, this can you can claim to be too close to 2, but this is definitely not close to 3, 4, 5, 6. Okay, that you can probably say. But this entry, the first entry differs by more than 100%. So, and also this is definitely not close to 7. This may be 8. This may be called 9. But yeah, well, I'm not so well. So in that case, I was find out why there's so much discrepancy. Okay, it's not like this disagreement with these entries is actually quite large. Why is that? I need to find that out for you guys and for myself also. Ridhima, you pointed out something which sounds to be plausible, but I'm still not sure why there is some entries differed so much. And well, some of you to try to find this out. That is how we learn. Anyways, uh, I was not expecting that, but it's a good thing that we have run into this problem. We may find something new. Let's see. Anyways, let's move on. I'll look it up. I'll find out the answer to this, and we'll get back to you the next class on Monday. Right? Okay. Okay. Some more routine commands. Uh, yeah, I think Chandrahas, I already answered your question. Okay. Any other? Any other? Someone else may want to help me. Uh, Anyone else who can help me with this? All right, never mind. Just find it out. Find out at least. Okay, now next routine command is basically accessing part of a matrix. So how do you access part of a matrix? So oftentimes you will require to uh, access a part of a matrix. Okay. So for example, if you have so say a simple command. Now this is a function matrix. Now we are going to look at not these are not square brackets or curved brackets. Okay, and if you give a issue command like this where m is a matrix, then what it does is it takes m matrix as a vector. Okay, with elements enumerated column wise. What I mean by that, column wise. Okay, and then lists, and then lists the entries from mth to nth elements. Okay, what it does is, so suppose I have a matrix, n by n matrix here. What it does, so first thing you do is you read, there is a, there is a, hello class, sorry, मेरी. Okay. So it reads those these entries. It constructs a vector. Remember, vector is a one-dimensional matrix, right? It constructs like this, goes like this, come back, comes. So sorry. So it leads first element of the vector, second element, third element, and so on, and then nth element, and then n plus one-th element will start from here, and so on. This will be two nth element, and then 2n plus 1. This way it makes a vector. So this entire information which is presented in matrix form is first transformed to a simple one-dimensional vectors. So this will be one, second, third, up to nth element would be this one appearing over here, then n plus one-th element, and so on. So this way it does that. Okay. And then out of that, suppose I had given a, if I requested to get me from, let's say, so suppose I had requested m x comma x y, x y, that would give me xth element to yth element in this uh, column, in this vector. Okay, so that is what this particular command implies when you have m as a matrix. Okay, if m is a vector, then it's very pretty obvious, right? So if it's a vector, then you just take xth element to yth element. That is just printed out for you. Okay, so let's just check this. Let's just check this. Let's say a. Uh, let's just check this 1 to 9. Okay, we already know a vector currently in use is this one. Okay, so let's see what does that give us. Okay, so so this gives me 1 4 7 2 5 8 3 6 9. So that's what I just told you, right? So it just goes, this forms a vector from element first to element 9, which is actually including all the elements. So first element starts here and goes like this, and then comes back up and goes like this. So uh, this is your that command. All right. Uh, Oftentimes you are required to find out eigenvalues of a matrix. Okay, so very simple command for that. Just eig of matrix. Let's say m here. Oh, sorry, a here. So that is your eigenvalues. These are your eigenvalues for matrix, whatever I defined here. Oh, so maybe it's because one of the eigenvalues is 0 here. That's why probably I'm having trouble with the numbers not matching closely. Okay, that probably a sign of why this is happening. Maybe I can check this with a different looking matrix. Let me go back and check again. So I'm going to, let's define a matrix called D is equal to something. Hope this eigenvalues are not 0. Okay, so let's just check its eigenvalues. All right, probably not 0, none of them. So what is that? Eigenvalue matrix with different value. Really? Is that so? Okay. So yeah, you guys have already an answer. Looks like good. I love that. So let me just go back. Arunima, is any real negative eigenvalues, then a complex result is produced. This is first. Hmm. Negative eigenvalue matrix is values with square root m, different value with square root m. Where, yeah, but the question is why is that happening? That's what I thought. Looks like. See, let me just check this. D. F equals to D star D. Okay, SQRTM of F is what? Okay, so that is 235. That's again not close at all. Huh. MATLAB says so. I'll write. Okay, sure. Thank you. We'll resolve it. But well, MATLAB says so, fine. But I need to look up the where does it originate from actually. Okay, we'll get back to this issue later. Okay, that's good that we have gone into this. Okay, all right. Thank you. Let's move on. Anyway, so eigenvalues you can find by given the command eig, and suppose you have to have sometimes you also have to have vectors, eigenvectors. So typically, for example, if I give a command like v comma d equals to eiga, okay, so that gives me both vectors, eigenvectors, these are the column vectors, and corresponding eigenvalues over here. Okay, so these are the, I mean, these vertical columns are the column vectors or eigenvectors, and these are my eigenvalues, which appear on a appear at a diagonal element in the matrix D. Okay, all right. Okay, next thing I just want to. Okay, a lot of times um, you need to, for example, if you ever create a vector which is somewhat has some kind of regularity, okay, or some kind of pattern. For example, they are all, let's say I'm going to create a vector which is 1 2 3 4 5 6 7 8 9 10 that runs like that. So I don't want to write them. There should be a very easy, there should be a way to construct it, okay, and very simple way to construct it. For example, if you just give a command like v equals to 1 is to 6, it just gives a vector like that. Okay, another functionality to this kind of command is you can, for example, if I have three numbers separated by colons, okay, then it tells me that start from 2 and do not go up beyond 10. Okay, so it says me that start from 2, the left first number, this is the maximum value, and this is the increment. The central one is the increment. Okay, that will give me the 2, 5, 8, and that's it. Okay, so this is going to give me 2, 5, 8 because the next to 8 would be larger than a maximum. All right. Now, if you want to access you can do the same thing with a minus sign as well. So, for example, y equals to 1 colon minus 0.25 and 0 minus 0.250. Uh, yeah, right. So this would give me a 0, right? Because this is not going to, minimum value is 0. So 1 minus 0.25, y is 1. Oh, sorry, I made a mistake here. I put a semicolon here. Should have been colon. Okay, now here we go. All right, so 1, 0.75, 0.5, 0.25, and 0. Okay, all right, so now accessing a matrix element, how do you access a particular element? That is simply by giving the command, which is aij. Simply, so suppose I have access, it's like, it appears like a function again. So it's just kind of special form of this one. Well, this one is actually a vector, but accessing a particular element of matrix, okay, let's say A, that is basically done by issuing a command ai comma j within the curved brackets. Okay, so this is what gives me aij, ith jth element. Okay, so let's say a2 comma 3 is going to be like 6. So if you just look at matrix A, by the way, you can also go to the workspace and click on the variable, double click on variable, it should, sorry, where did it disappear? So here it is. When you click on it, it displays that variable values in a spreadsheet kind of form, right? So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Rather than variable, changing a particular variable over here, the console window, you can also change it by just looking up the spreadsheet form of that. Suppose I changed this number to some other number, A will automatically change. So that is another way of changing, which is more user friendly. Okay, this is a good feature in MATLAB where you can just click on the variable and make changes over there rather than issuing a command. Okay, because in command you have to probably look up what command to use. Here I can directly change it. So it's a kind of graphically you can change it. Okay. All right. So what I did is A23. So second row, third column. This one is a 6, right? Anyway, so that is how you actually access a uh, particular element. And if you give a command that looks like that is basically say command that is C, which is where C is a matrix, and let's say I1 colon I2 comma J1 colon J2. Okay. So what would happen in this case? Basically, uh, row indices these from here to here and column indices here to here, that will be extracted out. Okay, that part of the matrix will be extracted out. So let's try that out. So let's say A is equal to um, maybe, sorry, you can form maybe a matrix which is 6 by 4. I'm just typing some random numbers. So I have 6 rows and 4 columns. Sorry, 4 rows and 6 columns. Okay. So I have 4 rows and 6 columns. Okay. So I have 4 rows and 6 columns. And suppose now I give a command of A, 2, 4, comma, 3 to 5. Okay. So that gives me 168262935. So that is this part, well, 168262965. What it did was it went from second row to fourth row. So you can imagine drawing a line like this, and this. Okay, so draw horizontal lines for the row elements and column lines for uh, these numbers. So third, fourth, and fifth. Wherever they meet, those are the elements which are picked up. Okay, these elements will be picked up as your result when you do issue this command. Okay, so maybe I can explain it over here. So if you have a matrix, okay, and you have this one, this is a matrix, and let's say this is well, um, so this is C looks like this. These are these are the row elements. And tab is slowing down. Okay. And then suppose this is your I1 row and this is your I2th row. Then you draw these up to this and say this is your J1th row column and J2th column. Then you draw these lines, and wherever they meet, these elements will be actually picked up from issuing this particular command. Okay, so that's what this command. So you can basically filter out a particular chunk or particular part of a matrix. Okay. Um, Now there are certain simple, quick commands to construct a very commonly used matrices, like constructing an identity matrix. There is identity matrix or zero matrix, where all the matrices are zero. Okay, or matrix of ones, where all the are ones. Matrix of entries one. Okay, so identity matrix is given by command called EYE, and that would be n by n. So you can just, if you give 3 by 3 matrix, 3 comma 3. So a command that is issued like I EYEI 3 comma 3, that will give me 100 010 010 001. Okay, that's an identity matrix. And similarly, if you have zero matrices, zero, that is given by zeros, ZIROS. And again, here you can give different, here you're allowed to have different rows and columns because all of them are zeros. Okay, so that would be 3 rows and 5 columns, and like that. Okay, so that would be your zeros. And similarly, ones, and here you can give m and n. Okay, separated by comma. You'll get all the elements. So that would be 1 1 1 1 1 1 1 1 1, etc. Okay, with m rows and n columns. Okay, all right. So that is about uh, okay. Hmm. Next important thing. Let me see. What else I need to tell you? Hmm. One important uh, information you often need about a matrix is its size. Okay, so size of a matrix is size of a matrix. So that if you just go, if you just issue a command m comma n equal to size of a. Okay, so it will give me number of rows and columns like this. Okay, so for example, if you had a size of a, so size of A. I should get four. A is 4 by 6. So 4 rows here. The last time I used A is over here. So I have 4 rows and 6 columns. Okay. So I get 4 by 6. Okay. And you can store it in a variable. So if I issue a command like m comma n, so if I issue a command like m comma n within a square brackets, that is equal to size of A, and then enter. Now if I hit M, I will get 4, and if I hit N, I'll get 6. So those entries were stored in the variable name M and N. Okay, and that you can process together. So you can say that A. Well, let's not get into that, but I think that is made clear. Um, Now length is what does length do? Length of A is 6. So what does length do is the following. By the way, sorry, because acha, yeah, get back to that. So, so, so what does length do? Mm, it gives you the bigger value of M and N. Okay. So, where is the length? So length of A gives the larger of the two dimensions of A. Okay, so it's m by n. Then it will be get whichever is larger will be given. Okay, so if A is a vector, A is a If you can identify A with an area or shape which is rectangular, then length is by default defined like that. Okay, the larger dimension is length. Okay, so that is the logic behind defining this length. If you have a matrix A and if you add to it some number, scalar number, okay, and here this is a matrix, then all elements of A, so this is B, then all elements of A is added uh, by 4. Okay, this would be like A11 plus 4 A1. So Bij, that would mean that Bij is equal to Aij plus 4 for all ij. Okay, so that would mean that all elements of A are basically added by 4. All right. Um, these are some of, well, I cannot talk about all the details. So when you actually, the best way to learn these things is do problems. I mean, do not the small problems, but do a big, like a project kind of thing. Okay, and when you do a project kind of thing on using MATLAB, then you get to learn a lot of things which will be actually etched into your mind. You will never forget. And just learning it like this, like I sometimes, a lot of times, I forget a lot of things because I don't use it very frequently. I use it, but not very frequently. So that's why you have to just keep using it. And the one way of doing it is you do an extended project. Okay. All right. Um, Division. Now, matrix division. Um, so, so there are two ways to. So one way to give a command. So if you have a backslash b, this is equivalent to A inverse B. Okay. So remember, dividing matrix actually dividing is like in multiplying with an invert, right? Inverted matrix. So you can pre-multiply or post-multiply. So you can have A inverse B or B inverse. Okay. So this thing is basically A backslash B. Okay. All right. Uh, okay. So this would be basically if you write it like if Cij. Now, suppose I had to do, so this is like, this is the matrix multiplication. You take the A inverse, multiply, do the product. You know how matrix are multiplied. You just do that, okay? But suppose I had to do element by element division, right? Meaning that if I had an element, if I have matrix Aij is here, A11, A12, A1n, A21, A22 up to A2n, and I have matrix B11, B12, B1n, B21, and so B2, what they write here, that should not be n, that should have been n, so n1, n2, and n, and B and 1, B and n. Okay, now I want to construct a matrix where this is divided by this is divided by this. Element by element division is basically done. Okay, so this division is basically taking from this and this. So that way you have, suppose I have matrix Cij, which is Cij is equal to Aij divided by Bij. Okay, so how do you construct C matrix in that case? MATLAB has a provision for that. So if you just give C equals to A dot forward slash B. Okay, so that would imply this operation. Okay. Um, okay. So one thing I just want to point it out here, and I'll stop with this statement, which is A dot backslash B is equivalent to B dot forward slash A. You just check this, and I'm going to stop with this statement today's class. Okay, you just check this. Okay. All right. Again, I'll repeat: a dot backslash b is equivalent to b dot forward slash a. So forward slash and backslash have different meanings. Okay. We'll start from here. Okay. All right. I'm going to stop. Any questions? Just check. So this shows the square term example correctly. You found an example? Good, good, good. Thanks, Rohit. I'll keep that in mind. But I'm just let's find out why this is happening the way it's happening. Okay, why having a negative eigenvalue makes a difference. Okay, okay. We'll. Any other question? Satvish says something about because of characteristic equation. I still don't understand what is the nature by what way does a problem creep in. Okay, that I want to know. I want to understand that. Okay, let's find that out. All right, I'm going to stop the class, and see you tomorrow. See you on Monday. Bye bye. Stop sharing. And yeah, I